Hi, this is Mrs. LaBarbara. Today's topic is force and its representation. The objectives for today is to know the types of forces. What is a force? Now we learned force is push or pull, but force is also interaction. When the force is unbalanced, it will change the object's motion. That means the force will change the velocity of an object. When velocity changes, force causes acceleration. All forces between objects can be placed into two categories. One of the category is called contact force. Contact force results when the two objects are touching each other and the interaction from touching each other, contacting with each other. The other type of force is action at a distance force, which results when objects are physically separated. So the force that's touching each other, we know from our everyday experience could be friction, right? You have friction or air resistance and something goes through the air, touching air molecules, or you're pushing a block on the floor, that block and the floor touching each other. That is the contact force. Action at a distance force, such as gravity. You throw a ball up in the air. Even though the ball and the earth are not touching each other, that ball is going to fall down. So that gravity is action at a distance force. Here are examples of contact force and action at a distance force. Basically, action at a distance force, we have gravitational force you're familiar with. The other one you're probably familiar with is magnetic force. When you put the two magnets next to each other, you could feel the force. Either they repel or they attract, even without touching. The other forces like applied force, tension force, spring force, normal force, frictional force, or air resistance force, those are all contact forces. We're going to go through some of the forces in detail. First force is weight. We already know weight. Or force of gravity. That is a non-contact force. That's an action at a distance force. That is force you don't need to touch in order to experience it. So force of gravity is the force at which Earth, Moon, or other massively large object attract another object towards itself. By definition, it is the weight of the object. So force of gravity and weight can be used interchangeably. So all objects on Earth experience a force of gravity which is directed downward. That means toward the center of the Earth. That's the direction of that force. And the force of gravity on Earth is found by this equation. W equals to Fg. Weight and gravity are the same. That equals to m times g. What is little g? 9.81 newtons per kilogram. This little g, 9.81, we've seen that before. That's acceleration due to gravity. It's also is the same. This unit, Newton per kilogram, is the same as meters per second squared. So this value is on the reference table. This value is only 9.81 on Earth. That means on Earth means doesn't have to touch Earth. You can be 10 meters above Earth or 100 meters even. So it's near Earth. That's what it means. The direction of gravitational force is always downward. For example, what's the direction? This is like a loop. You're going for the ride. So at each point, the direction of weight is downward. At each point, the direction of the weight is downward. This is a football. When it's going in the air, it doesn't matter where it is. The direction of gravity is always downward. The next force is normal force. What is a normal force? Normal force is a support force. Normal force is contact force, so it has to touch. Has to touch usually a surface. Has to touch a surface, so the surface can support the object. For example, a table, this looks like a block of wood on the table. The table is supporting the block of wood. So the direction of the normal force is perpendicular to the surface. So perpendicular to the table and toward the object. In this case, the object is the wood. Here is person lying against a wall. So the wall is a surface. The normal force is the wall supporting the person. So it has to be perpendicular to the surface, to the wall, and toward that person. That is the normal force. Here is a person skiing on a slope. So the surface is a slope. The normal force is from the surface, from the slope to the person. The direction has to be perpendicular to the surface, perpendicular to the slope. So here are the direction of the normal force in the examples. So again, this looks like a ride, a loop ride. So the surface would be the loop. At this point, it's supporting the object, so it would going upward. At this point, it's kind of pushing the object down. That would be downward. That's a normal force. This one supported the object perpendicular to the surface toward the object, right? This one is up. This one is to the right. This one would be to the left. So as you can see, all these directions are perpendicular to the surface toward the object. Similarly, all this also has to be perpendicular to the surface. The surface looks like a little hill. And it's toward the object, perpendicular. Over here, this is a tricky question. What is a normal force here? Well, there shouldn't be any normal force because there is no surface. This is the arc of the football. So this is a path. There is no surface, so there is no normal force. The other one is a spring force. So you have a spring can go vibrate back and forth. The spring force is the force exerted by a compressed or stretched spring on any object that is attached to it. An object that compressed or stretched a spring is always acted by a force that restores the object to its rest or equilibrium position. So as the object stretched, there is a force going to push it this toward its center. When the spring is compressed, the force is going to push the object to the right. So there is always a force trying to pull the object toward the center, toward over here, center. Okay, always going here, coming back. The magnitude is F equals to kx. As you can see, the force changes directions. In this equation, k is spring constant, x is the elongation of the spring. We're going to study this equation in detail later on. Next force is sliding friction. I put sliding friction because there are other type of frictions called rolling friction. So sliding friction, the friction force is the force exerted by the surface as the object moves across it. The sliding friction force opposes the motion of the object. That means the motion is its velocity, so it's opposite of its velocity. For example, if a book moves across the surface, then the desk exerts a frictional force in the opposite direction of its motion, of its velocity. That's what it means. The frictional force can be found using this equation. So we know the direction is opposite of velocity, and this is how we find magnitude. Again, we're going to go to this equation later on in detail. So how do we find the direction of a friction? Direction of friction is opposite your V. If the block is moving downward, friction has to be upward. Similarly, friction upward doesn't matter the inclination of the incline. This one, if the block is moving upward, friction has to be downward. So all this friction is always opposite of your velocity. This moving down, friction has to be up. Okay, this one moving down, friction has to be up. Another type of force is air resistance. Air resistance is kind of like frictional force. It is a special type of frictional force in which acts upon the objects from the air. The air molecules move against the object. So the force of air resistance is similarly opposed to the object's motion, opposite to its velocity. This force will frequently be neglected because it's negligible magnitude. It's not very big. So basically in the physics, in Regents physics class, we don't really calculate air resistance, but you need to know there is a force air resistance. It's mostly noticeable for objects which travel at high speed, such as skydiver or downhill skier, or for objects with large surface area, such as a piece of paper or a feather. Now let's take a look. What is the direction of friction? Here is a football again in the air. So at each point, that's the direction of its motion. And here is the friction force, opposite of V, opposite of its V, okay? Next force is tension. So tension force is a force that is transmitted through a string, a rope, a cable, or wire when it is put tight by forces acting from opposite side, like two people pulling on the string. There is tension on the string. The tension force is directed along the length of the wire, so tension is everywhere, and pulls equally on the objects on the opposite end of the wire. So if over here you'll have 900 newtons, what is tension over here? It has to be the same. So tension everywhere is the same. Over here has to be 900 newtons as well. Next force is applied force. Applied force is a force obviously applied to an object by a person or another object. A person pulling the sled, a person pulling down the bar, or pushing a box. Let's take a look at this example. So first, let's review. These are the forces we have learned: weight or gravity, normal force, spring force, friction, air resistance, tension, and applied force. Ignore air resistance, says in this example. Draw all forces on M1 and M2. So here is M1, here is M2. First, do we have weight? Yes, weight is acting on all objects. So the weight is downward. Weight and weight. Another thing, do we have normal force? Yes, we have a surface. So there is normal force on M1. But there is no normal force on M2 because M2 is not on the surface. Next one, we don't have spring force because there is no spring. Do we have a friction? Yes, the object is moving. So it's moving to up, the friction would be downward. Do we have air resistance? This one says ignore air resistance, so there is no air resistance. Do we have tension? Yes, tension is on the string. So the tension is pulling this up, and the tension is also pulling M2 up. And there is no applied force. So that's the forces. Thanks for watching. See you next time.